21 people waiting. Yeah, there's 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? 21 people. Hey guys, can you all hear us? Is it still repeating? Is it still repeating? Is it still repeating? Testing. Repeating? No. Is it? Is it still repeating? Okay. Thanks. Thanks, Joe and Nicholas. All right, I'm going to share my screen now. All right. Welcome, everyone. So welcome to the Effective Data Storytelling Workshop. We are NUS Statistics Society. This workshop will be presented to you by Michael Eng, Michael Yang, Ming Liang, Peng, and me, Jet. So let's begin. So who are we? We are NUS Statistics Society. We are officially under Department of Statistics and Applied Probability, but we are open to all faculties. We are committed to foster a community of students passionate about statistics, data science, analytics, machine learning, and quantitative finance. So this is a photo, an old photo of us last time. So to keep track of our upcoming events, here are our social links. So we have the Statistics Society website over here. This is where we conduct all our publicity as well as showcase our events and past workshops. So this workshop will be recorded and uploaded on the website as well as all the slides and resources, materials that are used. So keep track of this website. The Telegram is where we share a lot of things. You can chat as well. No one's chatting for now, but yeah, you can start. There's Instagram as well that we use for publicity, and LinkedIn if you are more into the serious kind of things, and our email if you'd like to contact us. So what workshops have we had this semester? Early on the semester, we had a data science competition. And so we also gave a workshop there on applied computer vision. So this was a past event. If you're interested in that, you can go and look at the website where we have the recorded videos there. Today, we are having the effective data storytelling workshop. And next week, Thursday, we are having the Tidyverse workshop using Tidyverse in R for data analysis and visualization. So if you're the type to uses R, you can learn about this library called Tidyverse and use it for data analysis and visualization. So this is conducted by Sanraj and Jianhui, who are not from workshops department, but fellow friends from NUS Statistics Society. So welcome to our workshop. Introducing our workshops team, I'm Jet. We have Rama from Computer Science, Agatha from Statistics, Georgie from Computer Science, and this is Yizhe. This is Yizhe, Ang Yizhe from Data Science Analytics. So they presented the workshop for the data science competition. And our presenters for today will be Michael Eng from Data Science Analytics, Peng from Quantitative Finance, Ming Liang from Computational Biology, and Michael Yang from Data Science Analytics. Now let's begin. Now let's pass time to Michael Yang, who will bring us through today's workshop first.
Hey, hopefully everyone can hear me. Let me share my screen real quick. All right, so hi, my name is Michael Yang. Like what Jet explained, I'm a year 2 data science analytics student. I'll be explaining to you how you reduce your cognitive load. Now, I think the first thing y'all will notice is the word on the bottom, on the left side, it says Gestalt principles, and you're thinking, wait, this guy is like a data science major, right? And I'm pretty sure most of y'all are like psychology majors, year 4 doing your FYP, if I'm not wrong. Yeah, it's like, why is this fella telling me about reducing cognitive load, especially Gestalt principles, like things that you already know already, right? But hang on a moment, let me just try to explain what I'm doing here. Yeah, so as most of y'all know, there are probably 7 Gestalt principles, but I'm only focusing on 6 Gestalt principles for visual perception today. First one is proximity, second similarity, enclosure, closure, continuity, and connection. Now, probably most of y'all know this already, but some of them are actually connected with each other, some are associated with each other. But I'm trying to show you how you can actually use that to boost your data within your FYP, or even better, to actually make things easier for your prof to read at the end of the day by telling them a better story. Now, before I move on to Gestalt principles in general, first question, why do we need to reduce cognitive load, right? So in a large intuitive sense, it makes a lot of sense if I can see everything, if I can be almost omniscient within my data, if I present my visuals and in one look, my prof or someone else was looking at my data set to like, wow, I see everything. That sounds like a pretty ideal situation. But on hindsight, it may not be the case. Why? Because, well, data can be overwhelming. You have maybe 5,000 entries of things that you want to show your prof, but your prof doesn't have 5,000 eyeballs to look at all of them. So you gotta only choose the ones that are really, really important and highlight what's truly important to your prof. Secondly, your client, i.e. your profs, who is reading your FYP, that poor fella, bless his soul, may not have the time or attention span to decipher your data. In other words, he might have a long day, unfortunately. He's probably reading your FYP around 1 a.m. Like I said, bless the poor fella soul. So you really want to guide his attention. You really want to make the life easier by guiding them towards where to look. For instance, hey, we found this trend that's really cool. Let me draw a line for you so it's easier for you to take a look at it. Don't worry, we'll cover more about that in a moment in time. But let me just finish. Highlighting, it also highlights data trends. So like I said, drawing a line, highlighting, boxing things. These will then tend to guide your profs and rather the people who are reading your data towards where to look, and give them a striking insight into what you're trying to deliver. And that brings us to delivering the message. Because at the end of the day, a lot of data visualization tools are meant to send 1 or 2 messages away. At least that's what people usually take away from the meeting. 1 or 2, at most 3 things. Well, the power of 3 is powerful. So you really want to use that visualization to give them that one takeaway they can really take home with, instead of trying to focus on multiple things at once that they cannot try to focus on specific things. Now, moving on. Let's talk about proximity, right? I think most of you know this already, but if we group things together, people tend to associate them together. In other words, if I try to split them into rows like these, y'all can see that y'all will see the groups of columns as a single group, and y'all will automatically associate them as one entity. So how does it actually apply to our data? Well, if you want to highlight trends within rows, you can place horizontal entries together. In other words, put the spaces in between horizontal entries smaller and increase the space between rows. That means that gives you that highlights your rows as a trend. If you want to do the opposite, i.e. trying to place your columns together, then you can reduce the vertical distance between entries and increase the horizontal distance between entries. That gives your audience a bit more, that will guide your audience into focusing on either the columns or the rows. Now, that's quite intuitive, isn't it? Now, moving on, let's go to similarity. This is the part where everyone gets a bit more, where people don't really try things out, in the sense that it seems there are sometimes a bit more work involved in processing data, for instance, color coding. But what this essentially means is that when people look at things that are similar, they tend to group together. So for instance, the vertical patterns here with the circle, also the cross. That gives us a very strong indication of these things are grouped together. And it's almost striking the moment you look at it that these belong to the same group. Now, how can you exploit that when you're doing data? Now, depending on the software they're using, some people will be using Python, some people will be using R. Later, Ethan will be introducing JASP, which is also an extremely useful data software that allows you to process data in various ways. Now, in most of these cases, you can control the font type and sizes, especially the color. Now, having these codes, having these attributes being controlled within your data in your visualization allows your audience to be guided in terms of where to look. And when this attribute almost jumps out to them in plain sight, they cannot help but to focus on where they are looking at. And that's exactly what Similarity is trying to achieve. Now let's talk about enclosure, right? So enclosure, as the name suggests, is things that are enclosed together, regardless of box, a shaded zone, an oval, whatnot. So framing these things together allow us to associate them, not just in terms of, hey, these belong to a single group, but also the fact that sometimes you may have things that are actually not approximate to each other, but when the moment you enclose them together, they actually seem like they belong in the same group. So you can even argue that enclosure effect can even be stronger than proximity or even similarity. Yeah. So with that, how do you actually use that in your data? Well, so some people like, in fact, I'll make a test animation right here. I love to draw line charts. So line charts are a beautiful way to show trends. In fact, especially if you are dealing with temporal data, if you're dealing with things that are a bit more X to Y axis, run to flight kind of thing, line charts are wonderful at highlighting a trend. But line charts can be overwhelming as well, because line charts are usually very long drawn out and they are they have a large amount of entries within a single axis. How do you truly highlight the specific part where you want your client to focus on? Well, you can box them, you can highlight them, or you can even do funny things like bling 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 within a specific area. Well, I'm just making a joke here, but the idea is that you can enclose them into a specific region and guide your audience towards looking at that area. That gives your audience a bit more idea of what you want to show them. And of course, because of the bling bling blingness, they cannot help but to look at the original data that you want to guide their attention towards. Now, with enclosure, there is also closure. Closure generally means that people prefer things to be simple. In other words, right now you're looking at, well, I would say 3 Pac-Mans if you don't ask me anything about, we just flat out ask about one single object is probably a Pac-Man. But if I arrange these 3 Pac-Mans in a funny but regular way, a lot of people will say that they see a black triangle. But that might not be the case, right? But sometimes we, in order to make things simple, fill in the blanks, and we like to draw the full pictures for ourselves because it's our brain simply processes them that way. It's easier for our brains. So how do we actually use closure to reduce cognitive load? So a lot of people love to put boxes. Now, that's not a problem. In fact, boxes make things very, very structured. They make things neat and they guide your design processes when you're doing data reports, markdown files or whatnot that you like to do. But sometimes to the reader, it may not be appealing because boxes actually make things look a bit more easy. So if we learn to cut down things that are actually not necessary, they look cleaner. And not only are they more pleasing to the eyes, but if you take a look if you start imagining that this is part of a report and looking at boxes versus a non-box parts, you start to notice that you spend a lot more time focusing on the line trends here rather than being distracted subconsciously by the black and gray box that's in the background. Now, that effect itself may not be as pronounced as a lot of people think, but especially for someone who is going to scrambling around desperately looking for data points and trends to suit their experiments, this is something that's pretty strong. In fact, it can annoy someone who's trying to search for a specific trend that they're actually looking for in their research. Now, that brings us to continuity. Like previously, closure, like I said, there are connections to every single principle almost. The brain actually likes to fill in blanks, right? So just now you saw 3 Pac-Mans just now. What if I continue to draw that connection for you and say that, hey, now I have 3, well, we call this caret signs that's rotated. Once again, these are just 3 Pac-Mans, 3 caret signs. But if we combine these principles together, we can now see a white triangle that's even stronger than the previous black triangle. And this is because this actually exploits both the property of closure and continuity at the same time. Continuity simply means that we want to fill in our brain. Like our brain like to fill in the missing lines, the missing connections that are within a certain shape. Now, how can we actually bring continuity into the picture to allow us to reduce mental load so that someone can actually look at our visuals? The answer is, well, sometimes you don't even need exits, right? So just now I told you about you don't need boxes, you don't need to box up all your things together to compartmentalize them. But now I'm telling you, sometimes when it comes to axes, you can cut them off as well. But do that with a pinch of salt, in the sense that sometimes if you really cut down axes, your graphic charts can be really unquantifiable. But for instance, if you're just trying to make a comparison without specific stat lines, you can actually remove certain excessive components. In this case, we mean your axis, right? So if what your prof, or rather what your client is interested in is not what is the hard number, what's the hard data behind it, or rather he just wants the answer of, hey, can you just tell me which product is better? Can you tell me which car runs the highest RPM? Let me put it in a side context. Hey, tell me which psychoactive drugs is more effective in treating a specific patient, right? So then you can just give them that comparison. And that is extremely striking to the first person who's looking at it and like, oh, right, company A actually does quite well. So with all these techniques, when you cut down on certain axes on an appropriate amount, depending on the needs of the client, or your prof, you can actually show them something faster, give them a lot more direct way of delivering a message. Now that brings us to the last point, which is connection. Now we tend to consider objects that are physically connected as part of a single group. That is regardless of what that is literally we are wired, no pun intended, wired to look at connections, to see the connections when things are literally drawn for us. Now, this physical connection is actually one of the simplest, but also the most powerful way we can associate objects with one another. Now, if you take a look at the objects below, if you still remember similarity, proximity, or even closure, well, this doesn't have that much to do with closure. I remember about proximity, similarity, these two principles especially. You can see that in this case, connection almost overrides these two effects entirely just by joining these 2 points together. You can see that there are points that are extremely close to each other, but they are not connected. But points that are further away from them are actually connected. Now we consider them as one point. And we actually it's able to separate the points that are approximate to each other as separate entities. Similarly with the similarity rule, in the sense that even with the large size and the different size of dots, we can still perceive them as separate groups the moment we join connections with the small dots. Now, when it comes to connection, there are multiple ways you can exploit or even use this property. But I'm a simple guy, so I just like to draw lines and connect points, and that's exactly what we do. If you're like me, you're like, hey, I have a lot of data points. I just want to see what I can do by drawing lines and see what I can do with them. No issues, my friend. That's exactly what connection is used for. Because as much as people as much as people love scatter plots because they actually show you the distribution of certain things, sometimes things are a lot easier if you actually draw the connections for people. Because simply people are, I'm not saying lazy, but people are efficient that way. The moment you draw the line for them, you can easily see that line. They can easily see the connection, the trends, and how that changes people. Although things may look or sound, intuitive, or like, hey, Michael, why are you telling me this? This is pointless. Like, this connection thing is just, people are doing it already. Hey, but the moment you start doing it, you notice, yeah, it actually makes a difference, especially when you have discrete data points that you would like to highlight the trend in. Now, that brings to the end of my Gestalt principles. Hopefully you all had fun, and I hope I didn't bore you all too much. Now, to move on, I think it's a good idea to show you off your examples of what data visualization is like. Now, the person who designed this slides is actually one of our graduate friends, Peng. He's actually a graduate fellow from our for SETSOP. But unfortunately, due to certain reasons, he couldn't be here today. And instead, Jet will be presenting on this part. So without further ado, I'll hand the time over to Jet.
All right, thanks a lot, Michael. Let me share my screen. All right, so now I'll bring you through what is a good data visualization, which is probably what you are here for, right? So this set of slides are created by Peng, but he's not able to join us today. But he has created this set of slides that are very useful and I think will benefit you a lot. He also created a document of the summarized content of this, which you can find from the website that we have just now. Scroll down over here to look at resources and you click on data visualization tips. You'll get a PDF of essentially the slides about this condensed into a document. So you can print this out, you can refer to it. This is done by Peng. So this is very good resources that you should use for your learning purposes. Now, without further ado, let's go into data visualization. So some content, section 1, we first explain what is the power of data visualization and what are some common misconceptions of what data visualization is. Then we share some data visualization tips, starting with understanding the purpose of your data visualization. So if any data visualization, there must be a purpose to it. Then we choose a chart format that tells the story correctly. So here, notice that although we use the word correctly, it does not refer to say, is the data presented on the graph correct? Are the scales of the axis correct? It's not referring to that. It's referring to the story. So what is a data story? So that data storytelling must be presented correctly by the chart format, which I'll explain how later. Then we proceed to leverage color to help tell stories. And finally, we share some effective data visualization tips. So Peng is actually a teaching assistant for a module a module that requires data visualization as one of the final projects. And so he has come across a lot of examples of good and bad data visualization. So he has condensed all his experience and tips into one single document. Now let's move on. So what's the power of data visualization? It turns boring information into a visual that our brains can actually understand. So the boring information here refers to data. The data set they collect from surveys, from data pipelines into a visual. So humans are, as you know, visual people that can interpret data easier when it is a visual. So some common misconceptions. So can we take a look at this diagram on the left? What kind of insights can we get from this? We see a lot of Microsoft, Activision, Sony, and a lot of a lot of words that in a font size that we cannot even see. So in this case, this is merely reporting data, and this is not a good data visualization. Although it is very detailed, it is not better. So now we want to understand the purpose of the data visualization. What's the purpose? The purpose is to enhance your audience experience, not yours, with every data visualization that you make. So the key thing here is, as a speaker, what kind of message do I want to convey to an audience? So in the data visualization, there is always someone who wants to report the insights and another one who is trying to read and understand the insights. So as a speaker, what do my audience think? So we should put ourselves in the audience shoes. What kind of data analysis will help the audience interpret and understand the insights clearly and easily? So data is rigorous, boring, and redundant. So the processed data should be delivered to the audience in a clear and concise way. So we don't want to see Excel files, Excel tables. We want to see some visual so that the audience can understand insights. Choose a chart format that tells the story correctly. So here you can see what is an accurate chart. It depends on your use case. If you want to look at how values compare to each other, you look at something like a bar chart or a line chart. When you want to see how the data is distributed, you look at histograms or scatter plots. So, for example, when do you use a bar chart and when do you use a line chart? If you have some notion of when you use a bar chart, when you use a line chart, feel free to put on the chat below. I'm looking at the chat, so you can just share your answers there. Yeah, so we have here a bar chart and a line chart. Sometimes students or people actually, they use bar charts like line charts without any real purpose behind the difference between the two. But actually, a bar chart is used for variables that are distinct. So for example, the x-axis would be categorical variables, things that are not can be put on a single scale. While a line chart is something that is of continuous variables. So for example, in a line chart, you want to see the trend. So if you see here, you can look at what is going up, what is going down. For bar chart, you want to look at the absolute volume. That's why you can see that's why you see the full color in a bar chart. If you like to present exact values, you look at a table. So here you can bold certain values that you think you want to highlight to your reader. And if we want to look at how the data is distributed, you want the audience to see for themselves how the data is being distributed, you can use something like a histogram or a scatter plot. If you want to look at how the data is composed among categories, the pie chart tells us how data makes up 100%. So here you can see a rough ratio of how big each component is. If you want to look at certain values over time, we can use an area chart. The area chart shows us a visual of the area under the line. So that helps us to visualize this data. If we have more than one dimensions, we can use stacked versions of the graph. But in this case, it is not advisable if you want to compare between a lot of dimensions. For example, if you see here, you cannot really compare easily the second variable. Yeah, so use stacked graphs in your own, use it cautiously. How values relate to each other. You can use a bubble chart that will show you the absolute value with respect to, say, the x and y axis. You can use a heat map, say if you are using a linear correlation between multiple variables. So here the point is to choose a chart format that tells the story correctly. So it's not about reporting the data correctly, but telling the story accurately, concisely, and in a clean way so that your audience can understand it better. So line chart. A line chart can quickly show general trends. It's suitable for displaying trends of different categories in the same time period for easy comparison. So if you look at the left, this is very convoluted. You can see all kinds of places, I think. But this you cannot understand what is it trying to say. What is this visual trying to say? You can't tell. But if you look at something on the right where you split up each country into a separate graph, you can see very clearly, for example, Portugal is increasing in growth rate and then slightly decreasing. For France, you see a sharp increase and a sharp decrease. You can see the trend very quickly and easily. For bar charts, you want to compare different values side by side. So a bar chart can show overall changes over time, like a line chart, but instead, using a bar chart allows you to focus on overall numbers rather than trends, because you can see the color, the volume, as indicated by the area that takes the graph takes in. So if you want to compare between variables, the diagram on the left is a bad example, because, for example, if let's say we look at 2003, we want to compare between a full-time tenure faculty versus a full-time non-tenure track faculty. In 2003, we have to first look at the color and then find the bar that correlates to the year, and then try to imagine a line that draws across. So this is not a good diagram. In contrast, you look at the one on the right, we want to compare, if your intention is to compare between non-refund cancellation rates by deposit type versus no deposit or refundable, you can see very clearly that this is obviously the largest percentage. Now, following with a pie chart, The pie chart tells you how each value constitutes the whole. So previously we see relative values, but here you can see how each component makes up 100%. So one good rule of thumb to use is to have 6 or few categories. So if you see on the left here, this is too many categories, and you cannot tell how it compares visually. But if you look at something like this on the right, there's only 1, 2, 3, 4, 5, 6, and then the last one being other animals. And you can see very clearly, birds and rats have the same percentage. Mice is the most, followed by fish and cattle. A scatter plot is used when you're looking for correlations in large data sets. So this happens when you want to show your reader or your audience exactly what is this correlation between certain variables. So adding a trend line will help to show the correlation as well as statistical significance, but do use trend lines cautiously, because a trend line may not fit the data correctly. For example, as you see here on the right, we can add a linear regression line here, but it could very well be a decreasing curve. Like an exponentially decreasing curve. So comparing it with the left, though, the right one is already very good. The left is it's a scatter plot, a mixed scatter plot of many different categories. In this case, you cannot tell what is the general trend of this scatter plot. So next, we can also leverage color to help tell stories. So do you know that the choice of color can be even more important for data visualization than the data? So effective visualization, right? The point of it is to filter unnecessary information, interference, to facilitate deeper understanding of data and conduct information mining. So we want to help them to filter unnecessary information and understand insights clearly. So color can help us do that. So if you have come across this before, the color can affect the psychology of your audience or your reader. For example, many social media companies use blue, which signals trust. Here in this diagram, it says that blue denotes communication, globalization, and dependability. But if you notice F&B, they are usually using yellow and red, as you can see at McDonald's and KFC. They are used to represent optimism, energy, health, and decision making, apparently. So color really can help with understanding insights at one glance, and it may affect your reader or audience more heavily than, say, the way you do your data visualization. So one way to use colors in your data visualization is to use color shades. So the use of color shades express strength and size of the data. So for example, here we have cancellation rates by country, perhaps by, let's say, hotel booking or a country. So for example, here, if you want to highlight that Portugal is the country with the highest cancellation rate, you can color it red and the rest leave it as gray. This will contrast the value for Portugal against the rest of these countries over here. So this makes it more prominent with the use of color. So another tip is to use the same color scheme. So too many colors, right, adds noise to the data, which can distract the reader because it adds to the burden of reading. Instead, use the same color scheme. For example, here, predicted hotel demand by room type, we use a general hue of blue to green. So here we can see that the lower the percentage, the more green it is, the higher the percentage, the more blue it is in this pie chart. Or if you are using different shades of gray, you can, you can use similar colors so that it will not distract from what you are trying to highlight the most, which is in this case, the ridge regression model. You want to avoid bright colors because the audience can feel like you're shouting at them and distract them from the insights that you want to tell them. So the focus is on the story without being overwhelmed by the bright color. So in this case here, one easy way is to switch from using this bright yellow neon color into something that is much dimmer, but also showcases the contrast between USA and perhaps other countries. We want to highlight and use faint colors to ignore less important information. Don't use more than 6 colors in the report. This is a general rule of thumb. So in this case, usually you can use just 2 or 3 and it would give the same insight. So if you look at the 2 visualizations on the left, you can tell, how do you feel? The one on the left, the one on the top feels a bit, that there's a lot of colors in there, you don't know what to look at. But when you look at the diagram below, you can see very clearly that the person who created this data visualization wants you to focus at a time period from June to September. Next, you want to present effective data visualization. We want to consider limitations of the data display and efficiently visualize data. So one good book to use, recommended by Peng, is this book called Effective Data Visualization, The Right Chart for the Right Data by Stephanie Evergreen. So to end this segment, let's review some empirical conclusions that you can take away. So first, when the highlight, the data visualization must highlight and be informative. So the audience you want the graph to help your audience understand the content, and you want to let the core features of this data visualization to highlight the data and let it stand out by itself. You want to use annotations flexibly because it can help readers better understand the story you want to tell. We can make use of simple but powerful techniques. So there's no need to use fancy fonts and decorations. Use a simple font, use simple designs. You can bold or color to emphasize. And I think in the end, right, it is to put yourself in the reader or the audience or your listener's position. So if you are the one reading your report, how do you want to be told this story? Is it clear? Is it organized? Or is there some things that are distracting that is not making the same point as what you want to say? Yeah, so with that, that is all. And now I'll pass the time on to Ming Liang, who will share with you some case studies from psychology.
Thanks, Jet, for that introduction. Hold on, let me just share my screen. Hold on. Let's just okay. Okay, cool. Yep. So, yeah. Okay. So, sorry about that, but yeah. So, thanks, Jet, for the introduction on how to do good data visualization. So, talking about how to do good data visualization, let's talk about how we can try how this works from a psychology context. Right? So, some of you might be familiar with this thing called the Stroop effect. So I'm going to go cover it a bit for those who are not too familiar with it. So basically, the Stroop effect is the phenomenon of an increased reaction time, meaning a difficulty when we try to read the color of the words rather than reading the words themselves. So you can try this. You can try to say yellow, that's easy. But if you try to say blue, you try to sound out name the words by their colors, it's a lot more difficult than just reading off the words themselves. So that is the essence of the Stroop effect. You might be familiar from some game shows and stuff, but it's a very powerful tool and it's a very useful tool to understand attention. So to best understand how all this data visualization can be applied to this psychology context, I want you to keep in mind this phenomenon so that and put on your, the thinking hats of psychologists and try to think, how can we design an experiment and present the data from this experiment. So let's think a bit. Okay, so a very simple question might be, first, what are independent and dependent variables? So we can make a very simple setup. We can have a control group of just random words with some colors, compatible group, a congruent group of same words with the matching colors, and an incompatible or incongruent group of words with different colors. right? Simple things, and we can measure their reaction timing, right? So this is it. But of course, let's think, how do we then present our data? So let's suppose we collect our data, right? How do we then present it? Should we present it in terms of bar graphs? Should we present it in terms of pie charts? What do we present it with? So this is difficult because to know what we want to present, we need to know what are we focusing on. What do we want to emphasize when we see our reaction time? All right, so what do we want to focus on? What about the reaction time do we want to focus on? Right? So what is it? Well, let's think. Okay, so maybe some of you have realized, okay, it's actually very simple. What I want to focus on is the differences between these groups. And you're right, that's what we want to focus on. So is the bar graph the best way of doing this? Is the bar graph the best way of emphasizing this difference between the reaction times of these three different groups? Is there a better way? We can use a slope graph. So you notice this slope graph uses what Michael Young introduces in the beginning about reducing cognitive load, allowing somebody to just follow the line on this slope graph rather than trying to analyze the bar graph itself, emphasizing the differences between the different groups, experimental groups. Okay. So as psychologists, we might then ask something. Okay, now with this data, we see that, all right, it seems that color naming, yes, is more difficult than reading the words. But is this the end of the story? As any psychology student might be thinking, it's like, no, we should ask why. Maybe a professor will ask, why? Why is this the case? And then we might think, maybe one guess is that we practice reading since young, so it becomes very automatic. So it interferes with the fact when we try to name colors, because we're not so used to naming like the color of the words. Like nobody asks you to name the color of the word, but you're very familiar with reading the words. So maybe that's the reason for this conflict, And in fact, let's try to come up with a setup. We can do it. So one setup to test this hypothesis might be use different random shapes with some associated color. Okay. So we now try and test this hypothesis we have for why the strip effect can occur. And, we collect the data and we plot it out using our slope graphs. Okay, this is good. But the key thing is, right? What's the key thing here? So now we have two conditions. Before practice and after practice. Part A, graph A is before practice. Part B is after practice. And again, we can have three groups. Before and after practice, right? You can see that after practice, color naming becomes much harder than naming the shape, right? Because we're just practicing naming the shape, like practicing reading like that. And we see that after we practice naming the shape decreases in the amount of time to name a shape decreases, but it interferes with naming the color. Okay, so maybe it agrees with our hypothesis. But what's the key? But can we improve on how we visualize this graph? Emphasize on the relationships we want. Can this graph be further improved? Let's think. Can it be further improved? Well, of course, obviously, there is we can ask a question before to ask this, right? Again, what are we emphasizing on? Right? It's the before and after practice group, right? That's what we want, right? So now we are not so interested in the differences between the three experimental groups, but we are interested in before practice and after practice. So now let us use this insight to rearrange the slope graph. Ta-da! So you can see now first one is before practice, next one is after practice of naming the colors. We're performing in this case color naming, right? So you can see the differences between it, right? So you can see that the three groups become the 3 points, and you can see the differences in reaction time. Okay. So what does this all suggest? So the moral of the story is, whenever you think about how to improve the graph, think about what are you emphasizing on. Then reduce the cognitive load of what I'm emphasizing on, like maybe either using some kind of slope graph or any other techniques, right? What Michael Young has talked about, or the good visualizations Jet has talked about before, to then focus on and reduce the load it takes to process what is key, what is the key emphasis, right? So our key emphasis in this case is now not the different three groups, but the difference between practice and not practice. But not only is there an example of how psychologists can present data and how and there was an example, there's an actual example from actual journals about how the data is presented, but there are also common mistakes that people make that can be easily avoided. So just now some good examples and how we can maybe even come up with these good examples ourselves. But let's look at some bad examples now. So like I think what Mike Jet has been talking about, you don't really need so much fancy graphs when presenting data. You can actually always just use by avoiding common mistakes and knowing what to emphasize on, you can get some good visualization. So these are two graphs from two different FYPs. So let's look. Okay, so over here actually, I'm going to point out there's actually mistakes on these two, and they're actually easy gains. Actually, you just avoid them. So in this case, right, actually, if you didn't realize, they're actually meant to be two different graphs here. One is actually the random, which is this straight line, and the more jumpy lines, the curved line. That's actually an experiment, right? So, but off the bat, it might not be seen very obvious. So please use different styles when representing different experimental groups. And when you see this sort of bar graph, remember what I talked about. What are you focusing on? If your focus is a difference, consider using a slope graph, right? So yeah, use different lines and use slope graphs, right? That's the plan. Okay. So hopefully this gives you a starting idea of how what Michael Young and Jet have talked about in the beginning can help with your psychology project, right? By using the techniques of reducing overload, cognitive load, and remembering the key points of the data that we're trying to emphasize on, we can reduce the cognitive load such that people can more clearly and more easily see what we are emphasizing on. And by avoiding common mistakes, that will elevate your visualizations to the next level. And in conjunction with this, I'll pass my time over to Michael Ng, who will be talking even more practical tips on how to tell stories with your data now on a more general setting. All right, so you can pass the time, Michael.
Ming Liang, there is a question on the chat. Why do we use slope graph for that example? Isn't it discrete variables?
That's a very good question. So a slope graph is not a line graph where it's actually like where you actually can use discrete variables. So you must understand, slope graphs are not line graphs. So slope graph point is to actually highlight a difference, and it isn't to plot a continuous change like a line graph. So there are two different things. Yeah, I think that is the key. That's why slope graphs are different from line. That's why I didn't call it a line graph. Yeah, but that's a good question. Yeah. Okay. So yeah. So yes, you're right to also say that means the middle stuff doesn't have as much meaning like in a line graph. It's just to highlight the difference. Okay. Is there other questions? All right, cool. Okay. All right, thanks.
Yeah, I'll be sharing my screen now. Thank you, Ming Liang, for your presentation on your psychology study. Okay, hold on. Okay, so now, firstly, Michael Young has taught the Gestalt principles and how it can be applied for data. Then afterwards, Jet presented on the different type of charts that you can use, and for each scenario, which is the most suitable chart. And then afterwards, Ming Liang went through a psychology example. And now I'll be going through some practical tips, whether you are a psychology student or not, that I think all of us will find useful to tell stories through using data. So the first three tips that I will be presenting today will be to utilize storyboarding, to do explanatory analysis instead of exploratory analysis which is quite common. And the last one, significance tests are actually not very significant. So now I'll go on to my first tip, how to utilize storyboarding. When you hear of storyboarding, you might think, okay, that sounds like something like, people in Pixar or Disney use. And that is correct, because this term comes from the animator world, that storyboarding refers to a graphical representation used by animators on how a video should unfold, shot by shot. So before they create their scenes and put it in front of a camera, in 2D animation, they'll actually draw all of this out frame by frame on a separate piece of paper. This is so that they can focus on the ideas and the framing of their shot, and instead of just focusing on the medium. So we can use this tip for our data storytelling too. So how does it help? Because storyboarding allows us to focus on the ideas instead of just the medium. When you give a presentation on your data, do not plan your outline on the PowerPoint slides you are presenting on. Instead, have a separate document, or even you can use a piece of paper to write down all your ideas so that you can filter it, go through it, experiment a bit. And once you have a solid idea, then transfer this very good idea onto your PowerPoint slides. This will allow you to plan and to design your slides accurately and beautifully. So afterwards, I'll be going through the second tip, which is explanatory data analysis. So in most circles, especially even in data science, we always talk about exploratory data analysis. Short form is called EDA, where we want to show our clients or even to our professors, look, we have gone through every single column and these are the results that we are presenting. However, as you can look from this slide, there's quite a lot of things to look at. And as Jet said, we have to wear the shoes of the audience, see from their perspective. This 10 columns that I'm presenting in this slide is quite overwhelming. I'll get quite confused. What is it talking about? And actually, to summarize, these 10 columns, the graphs here, they show the relationship between the column and the monthly income. So as you can see, let's say for the one on the top left, job level, you could see that there is a very positive correlation between job level and monthly income. The higher your job level, the higher your monthly income. So this is a very bad habit, to plot everything to showcase your hard work. What you should do instead is to focus on the important variables, and then you drop the rest. So as you can see, I've filtered all 10 of my columns into 2 important columns, job level and job role, because I want to emphasize the relationship of job level to monthly income and job role to monthly income. So this brings me to my next point, that statistics matter, but not all statistics will help you. You should use data to further your argument and not to distract the audience. Having 2 variables, 2 important variables, can effectively tell my story instead of showing all 10. But having said that, you should not cherry pick your data to suit your argument. So what do I mean by this? I'll give an example using significance tests. So you may heard it in your statistics class or maybe even JAWS 1000. Okay, what is hypothesis testing, significance test, p-values? These are all under the same umbrella. So the thing is that as we may not be familiar with statistics, and we may think that significance tests are the end-all be-all, but they are only a small part of data communication. So let me explain what hypothesis testing or significance tests are. So first, we need a significance level, which is denoted as alpha, which is the probability of rejecting the null hypothesis when it is true. Okay, now you may be wondering, oh my God, there's so much technical jargon here. But let's go through it with an example. So let's say that I have one coin and I want to see whether it's biased or not. So I need to have 2 hypotheses, the null hypothesis and the alternative hypothesis. So firstly, the null hypothesis is that, okay, I think the coin is fair. And the alternative hypothesis is that, no, the coin is biased towards heads. So the experiment would be, I'll flip this coin 100 times. As you can see from the graph, if the coin is fair, when you think about it, how many heads should I get? What's the number of heads that has the highest probability? If the coin is fair, it should be 50, half. Half will hit heads, half will hit tails. So actually, we can draw a distribution graph to show the probability of getting this number of hits, assuming that the coin is fair. So as you can see, at the peak, is 50 hits. And then once you go up the more than 50, the probability starts to drop. Same thing when you look, when you have less than 50, the probability also starts to drop. So the probability of getting 59 hits and more is about 0.045. So if we denote the significance level as 0.05, that means our p-value, which is the probability of 59 hits and more, is lower than our significance level. Then we might think, okay, we can actually reject the null hypothesis. We can think, okay, since 59 hits is quite improbable, so that means, right, that we need to that I can safely assume that this coin is biased. So as I said again, the p-value of less than 0.05 means that a very unlikely event has happened. Because of this unlikely event, we can think, okay, I think it's safe to assume that the coin is not fair. This is what we mean by rejecting the null hypothesis. Of course, this is a very brief overview of hypothesis testing, but I think this example can help me explain what are all these technical jargon and why we should not use it all the time. That's because, think of it intuitively. If we have a p-value of 0.051 or a p-value of 0.049, one is above the alpha level, while another one is below the alpha level. But if you think about the probability of hits from 100 coin tosses, intuitively, it doesn't really make any sense for one to be called significant, while the other is not called significant, because they're about the same. So if you were to use hypothesis testing in your research paper, it is very important to state the exact p-value in your report. You cannot just easily disregard the p-value and say, oh, it's below alpha, so we reject the null hypothesis. That is not good data communication. It's actually very misleading and it's a no-go. And also, we need to beware that there are assumptions made using significance tests. Like previously, on my coin toss example, it follows a bell curve. It looks like the normal distribution. So, as a normal distribution, they are symmetric. Then that is why hypothesis testing is actually quite useful for this coin toss example. However, as you can see from this slide, the distribution is quite skewed. So actually, hypothesis testing may not be exactly a very good test to use. For skewed distributions, you might have to use non-parametric tests, such as Wilcoxon sign rank test. And also, sometimes, if your sample size is too small, as you can see for the coin flips, I use 100 coin tosses. But if we had 20 coin toss, we might have to use a different test, such as t-test. So as you can see, just using significance tests in your report or even in your data presentation may not be enough and may not be convincing enough to show that you have done enough statistics analysis. There are multiple tests out there that can help you, and you should explore all these different types of options. And I think to sum up everything that we have talked about, you also must understand that all of this requires experimentation. We cannot just, okay, I think a bar chart looks good, then we go for the bar chart. We have to experiment. We have to try out different types of tests to see to try out different chart designs also to see what is the best way to communicate our data. So there is a software that actually helps us to show our data very well. And this is actually a segue to our next section, which is our Introduction to JSP by Heng. He'll be sharing to you about how to use this software and how to do data visualization. So thank you.
Okay, thanks, Michael. Yeah, I will now share my screen. Give me a moment. Yeah, okay. Can you all see the screen? Okay. Yeah, so this is JSP. Before I start going into it, I'll ask a bit, as in I'll tell you a bit like what is JSP. It's basically it's a statistical software using BibTeX and LaTeX. And what can it do? Yeah, it's the same as most of the other statistical softwares. It can provide information that we may need for our research papers, given a data set that you provide it with, of course. The next question is, why should I use JSP over other softwares? Like, I know a lot of seniors have been taught like SPSS, so on. And I mean it's the backbone, but the reason why I'm recommending JSP number one is because it's free, unlike SPSS that was taught in like some mandatory psych stats mods. It can also do a lot of things like that we require as a bare necessity in psychology research, like there's ANOVA, t-tests, linear regression, and so on. Yeah, and there's no need to use code, so like you don't even have to enter code. Everything is toggleable, and as I'll show you later. Yeah, so there's no need to like relearn anything if you forgot. Yeah, so I'll just jump straight into it. For this demonstration, I'll be using a data set from a sample thesis. Yeah, you can find your own data sets on Kaggle if you want to try JSP out for yourself. But so first, you'll need a CSV file. And so I will use this one over here, this abke underscore data.csv. And so, yeah, when you open it, it'll just look like this. It's quite intuitive. So, and it tells you like double click to edit data. So if you do that, it'll actually open up Microsoft Excel and you can make any changes that you want. And they reflect straight away. So for example, you see under failure to maintain, on the second row, it's number 6. I'll say I just change it to a 9, right? And then, yeah, I change it to a 9. And if I press save, the number should be reflected up here as well. So it changes on the spot after saving. It's quite fast. Anyway, so this is the data set, and I'll just show you how you can use some of the different features that it has. I'll start with descriptive tests and statistics. So we can just throw in any number of variables that we want to check out. So for example, age, just bring it over, gender, failure to maintain, and they'll just slowly appear one by one, and they give you everything that you need, mean, standard deviation, so on. So say you want to make some plots for it. So you can do that as well. There are box plots, scatter plots, and yeah, most of the things are really, they're just toggleable. So you don't have to worry about making a mistake. Say you realize this looks pretty ugly or you don't want it, you can just uncheck it and it goes away. So say I want a scatter plot instead, and you can change a lot of the options. For example, I want to change the confidence interval. So right now it's at 95%, but say I want it at 99%. So I just need to change the value and it will update accordingly. And this is basically how JSP functions. So if you make an error anywhere, there'll be a warning message telling you what you need to change or what you need to do. It's quite intuitive, really. Next, I'll show some regression. So we'll just use linear regression. Oh, oops, okay. So I'm not sure too much about this data set either, but let's just try putting in, let me check, oh man. Okay, yeah, so let me just check, like you just say dependent variables, failure to maintain. for example. And yeah, it'll slowly start reflecting information. So we can just throw in the other covariates just to check it out. Slowly, yeah. And they basically just give you summary tables for what we need. Well, just a reminder, because as we have been taught in 2132 that you're not supposed to put the summary tables on in your research paper. So it's really just for clear referencing and for internal understanding. When you explain the research or the results, you still need to write it out manually. Yeah, but I feel that the graphs and the models will be quite useful. It will be able to help with some visualization as well. So say when I do some plots as well, we can just check them off and they will appear accordingly. Yes. So this is essentially JSP. I've only used it myself for descriptive stats, ANOVA, and regression because that's the extent of my knowledge at the moment. But I hope it's useful to anyone that's doing the FYPs or like further research, because when I found out that JSP was only being taught to like the year ones and year twos now, it felt a bit like the year threes and year fours were missing out on some efficient means of doing statistics, especially when it's considered tedious to some of us. So I hope it helps. And yeah, that's actually most of what I have to say. If you're interested in finding out a bit more, there's actually a few features that we do not typically cover, but it's worth looking around at. Like they have things like k-nearest neighbors regression and machine learning, and there's various other modules that you can check out. Yeah, so actually that's about it. And yeah, so I'm done. Thank you. And if you have any questions, you can feel free to ask in the chat as well. Yeah. If not, I can pass the time back to Jet.
All right, thanks, Ethan. All right, I can share my screen. Maybe you can hand over the screen share. All right, thanks. Okay, so that was a short intro to JSP. Thanks a lot, Ethan. Ethan is actually in another department in Stat Society and not in workshops, so thanks a lot, Ethan. So we have a lot of workshops this semester. So today is the effective data storytelling one. We have a tidyverse in R, if you're interested in R, next week by Sanraj and Jianhui. So you can check out our website here. Otherwise, thank you very much for coming today. If you have questions, feel free to leave them in the chat and we will answer them. So let me share this link, this feedback form link on the chat. Yep, so please give us some feedback for this workshop and so that we can prepare for future workshops. You can look at Telegram if you are interested in knowing the latest updates or when there's Okay, so I see a question, where do you get practice data sets? So Kaggle, there's actually a lot of sources that you can get QR code. So there's a lot of places that you can get data sets from. Kaggle is one. Kaggle is a place for data science competitions, and you can also get a lot of notebooks where people send their code, and and you can look at their code, what they're doing, and then you can learn from them. Maybe y'all can give us an example of how you use JASP to do ANOVA or regression and analyze the data into words in future. It looks super efficient and useful. Ethan, do you want to take this?
Okay, sure. Yeah, I mean, yeah, I think that's a really good idea. Okay, like I have to pardon me, I haven't used JSP in a while, so it's a bit like I'm a bit rusty as well. But it's the beauty of it is that honestly, it how I learned it was also a bit of trial and error. Like they teach the bare minimum. They taught the bare minimum in 2132 last semester, and like they just teach you, oh, okay, you click this and click that and click that, and you just sort of blindly follow. But then it's the kind where you just forget about it after class. And then the thing is, when I went back home to try it out for myself, it was still quite intuitive. Like you just need to read the check boxes and give it a shot. So it's actually not too complicated if you want to try it out for yourself. But it's also worth considering teaching in the future, like step by step. Yeah, we'll look into that. Oh. Okay. Now what?
All right. Does anyone have any other questions? So okay, otherwise I'm just gonna publicize our past workshops. Let me share my screen here. So Statistics Society, right, has a lot of workshops and events. If you look at our website, this is the workshop for next week, Tidyverse. We have slides attached here where you can see whether or not it will be relevant to your work before you even decide whether to join the workshop or not. So here, right, we have all the previous resources, the data science competition workshop on applied computer vision. The recording is right here if you want to watch it. We cover a lot of things. We cover principal component analysis which is a dimensionality reduction method. Everything's all here. We also have some events such as this career of data from the perspective of an industry expert. So this is by Mr. Hong Lin Zhang on 29th of Jan from he's from Ant Financial, I think. I think he was a senior data analyst at Apple, DBS, and Soitec. Yep, so we have all kinds of things. We have some articles as well, written by some of our members. So we have Michael Ng and Peng and Joel and Zheng's articles over here. If you like to see what these concepts are, we have about page if you'd like to know more about us, and if you'd like to contact us for some collaboration with the society or with events, feel free to contact us here. So someone asks, are we able to perform qualitative analysis using JASP? Yeah, Ethan, do you want to? Ethan, you're muted. Ethan, you're muted.
Oh dear, okay, thanks. Sorry, I thought I clicked on mute. Anyway, I think it's mostly for quantitative analysis. It depends what kind of qualitative analysis. It's probably not as, what's the word? It's not as, it won't be very in-depth if it's just the qualitative, because it's mostly just models and the values that are required. Yeah. I managed to find my 2132 project, so I could share how to do ANOVA to answer the previous question as well, if you would like since there's a bit of time. Should I do that, Jet? Oh, okay.
Go for it.
Sure. I think you should go for it.
Okay, I shall do that right now. Okay, screen 2, right? Okay. Yeah, let me share this. Okay, so I will try and I just contextualize the data a bit. So we were testing on the presence of lyrics and tempo in music and how it will affect short-term memory retention. So basically what we needed was we have 4 different variables. One is slow tempo, fast tempo, no lyrics and lyrics. And yeah, so it's A1, A2, B1, B2. So how I did it is I went to ANOVA and I clicked on repeater measures ANOVA. So I have it over here. So yeah, so I just drop down in this box and you'll be presented with these two labels. I label them tempo and lyrics, and you have the different levels. So so say I just want to label tempo as slow and fast. So you just type it like that and it will change itself and match the different conditions accordingly. And for lyrics, I can do that as well. So I just put put lyrics and no lyrics. Oops. Oh dear. Okay. Yeah, and just by typing that, it actually shows up. So these are the 4 conditions, and you just need to match your data accordingly. So I have my data in the respective columns here, and what I just need to do is attach it accordingly. So slow tempo plus no lyrics. I'll just put it at slow plus no lyrics, for example. But you need to do it in order. So for example, slow plus lyrics is the first one. So I click it first. And then after that, slow plus no lyrics. And fast, and then fast plus lyrics. And then fast plus no lyrics. Sorry, it's a bit confusing, but it's just mixing and matching. Yeah, and just with that, you will get all the values that you are required. So like you see, you have the summary table here that you might recognize from PL2132 if it's anything like similar to what I went through. Yeah, so there's also some descriptive stats and descriptive plots that I did previously. So you can just tweak it. Oops. Okay, wait. Okay, that is not there. All right. Oh wait, no, okay. Sorry, that's under ANOVA still. My bad. Okay. Yeah, so it's under descriptive plots. There's one more. And yeah, there's a lot of the different options that we were taught. And yeah, you can just click through all of them and just see, say you want to check your post hoc test, you can check. Like you got tempo versus lyrics. And it should be reflected somewhere here, yes, like post hoc test. And say you don't want it, you can really just remove it. Like I mentioned, it's reversible. Yeah, so you don't have to worry about making any mistakes because most of them can be undone. I think so far I've only encountered once where it's just like a glitch where I just press tab and like the JSP crashed on me. But besides that, none of the like statistics things have screwed up on me so far. Yeah, so are there any questions? So is that actually more like did I understand? Did that help you understand how to use ANOVA on JSP? Yeah.
Thanks, Ethan.
Okay, I guess
All right.
yeah.
Yeah, so if there's any other questions, feel free to send a chat. We'll just be here until maybe the crowd slowly dies down and I just conclude. Yeah, do please help us fill in the feedback form so that we can see where's our room for improvement. Yep. Yeah, we'll just stay until 9:05. Thanks. It looks so much more intuitive than PSPP. SPSS, is it?
Yeah, it's because the PSPP is the free bootleg version of SPSS that you can download on your laptop. Yeah, like it's very limited.
Oh.
Yeah. So it's like in 2131 where they taught us SPSS, and then they needed you to like do your assignment at home. But then no one has SPSS lying around, so we just downloaded PSPP to do it.
I see. Makes sense.
Wait, this is recorded. No, we went back to the lab. Sorry. like the correct procedure. Okay.
All right. Once again, thanks so much for participating in our workshop. So, having been organizing this workshop since winter break, right? We hope you have learned some useful knowledge about data visualization. So we hope you have as much fun attending as we did organizing it, and do look forward to our future workshops and events. Right. So if there's no more questions, let's end off here. Oh, before that, can JASP do power analysis? Ethan, can they? You're muted.
What's power analysis?
Sample size.
I think so. I think I recall that it is able to, but I forgot exactly how to do it. I can read the documentation if you want, like the step by step. Yeah, but I recall being taught it in passing in 2132, but it wasn't required. I think. Wait, no, I just can't remember. I'm so sorry. But yeah, it's definitely possible. Yeah.
Okay, I think let's end here. Thanks a lot once again, the team, as well as the audience, you guys, for your support in this workshop. Hope you've learned something. Let's end here now. See ya.